Hi there, everybody. I'm glad you decided to come in here and listen to me talk about this topic today. So I'm going to be talking about applying automated visualization techniques in the world of model-based engineering. This is something that we've been working on a lot with No Magic, and we're pretty excited to be able to share it with you today. So we'll have a brief introduction, then we're going to talk about the state of model-based engineering as it exists today, and SysML 2.0. We'll talk about those issues and where we are in the state of, in reference to big data as a wider problem, because you'll actually see that a lot of the problems are the same. Then we'll look at how some people have approached this solution, some case studies, and finally we'll go into a very brief time in the live software. This isn't a sales pitch or anything, but just to illustrate the concepts that we'll be talking about in a way that hopefully will hit home for a lot of you. So Sawyer software, probably most of the people in this room have never heard of us until yesterday when they mentioned us a couple of times. So we have been around for 25 years actually. We have our core competency in automated layout and visualization of graphs, and kind of through a meandering path we found ourselves in the SysML space, and I am serving on the SysML 2.0 working group to help define the visualization standards that will go into that. So we've been working very closely with No Magic because they're obviously very involved in the standards as well. So that kind of is what brought us here today, and while you have started hearing our name, and hopefully you'll keep hearing it. So we're actually not, historically, for most of the 25 years, a systems modeling or data modeling tool even. We're really about data visualization. We have a number of customers through a variety of industries, and you'll actually see how that plays into what we've done. So the state of model-based engineering, model-based systems engineering in particular, kind of looks like this. And you won't see, and there are a variety of vendors out there that are letting you build models, right? Some of them are more or less dedicated to the standard. Some of them are more or less responsive to customer needs. If you're in this room, you're probably among the lucky ones. And in our experience working with a lot of these tool vendors as partners, No Magic is extremely loyal to the spec, and they're also extremely responsive when things need to change. And you'll notice, actually, if you look at these, that none of these are magic draw diagrams, and the reason is because I'm about to badmouth them. So model-based engineering is in a state where you've got all of this power, right? You know, all of the things that you know Mike was talking about this morning in his keynote. You can build all of this intelligence into your model, and you can build these elaborate, beautiful systems, or these simple and beautiful systems that describe the things that you need to know. But the limitation is that once you have described your systems, getting out a description of them that is exactly suited to the question you're trying to ask today, and even more so, the question that your manager or your executives are trying to ask today, can be very hard. And the problem is that diagramming, even more so than modeling, is this very labor-intensive task, right? So, you know, the estimates that we're getting from folks that we're working with is that up to 80% of their time, they're just rearranging diagrams or recreating diagrams, when the model itself, the real work, is already done, right? As soon as you create this diagram, even if it's linked to the core model, there are things about it which may quickly become out of date, right? If there's element insertion, if there are, you know, changes that are reflected, if just the picture that you have isn't really the complete picture that you intended to create, right? Your diagrams, especially once you export them from your core tool, become documents, and you're almost back in, you know, your document-intensive systems engineering world. They tend to be static, so a document tends to be a bit dead once it's been created. There are some things you can do with it, right? I mean, but especially once it gets out of the native tool environment, it tends to be a very dead object. And UML, you know, I don't think it will come as a shock to anyone that most people don't look like looking at UML, right? They just don't understand it. It's not user-friendly. If you're a modeler, it's great, right? It's got a lot of semantic meaning. It's very rich. It gives you a ton of very precise, rigorous information. But if you're anyone who doesn't need all of that information, it's just ugly, right? And it's inaccessible. So you end up with a lot of the time, most of your functionality, most of the richness gets tied into a particular thing that you need to have installed on the machine of anyone who you want to interact with that model in any way richer than seeing, a PowerPoint slide, right? So you can export stuff, but that's kind of where you get left. And so this is where we see, despite all of the very real value and power that is in MBSE today, this is where we see it falling short, right? And it turns out that this is a specialization of a much broader problem which has been faced, by a variety of industries, which is kind of the big data problem, right? You have objects, you have relationships between those objects, you have descriptors of those objects which may be temporal, right? It may have to do with, a date on a calendar, it may have to do with a milestone or a revision. There may be geospatial components depending on the type of system you have, and the descriptors of these data may not all lie in a single source of data, right? You may have, Mike Minarsik talked about federation as being key to this problem, right? And really we see that in practice all over the place. So this big data problem is actually something that brought Tom Sawyer into this space, and it's something that we've been solving and seeing forever. So big data, you need to solve this in different ways, right? So defense and intelligence, right? So you need to connect the dots. You need to figure out this crime. And obviously, we are all familiar with this movie trope of, this crazed investigator who cannot be stopped. And you walk into his office, and on the wall are all of these photographs and case files, and he's got pins and string that connect them, right? He's trying to solve a big data problem manually, right? And if you're working in a diagramming tool today, you're a little bit ahead of that, fortunately. But this is the same type of problem, and you see the same thing in information technology. You need to see networks in the early days, your office network was 50 devices. Maybe it was 100 devices. And so you would manually arrange these things, and you could get your status updates. But networks scale. Your models scale, right? And they outgrow your ability to manually maintain and manually view this data. And similarly, financial services, right? We had very prominently Panama Papers, right? This was a data model of financial transactions. And the only way it got cracked was by applying big data approaches of both analysis and visualization to understand it. Similarly with electric utilities, right? If you need to draw a power grid for an entire city, yeah, you could do that by hand if you had years, right? Or you didn't really care what it looked like, but you're going to want to have these types of approaches that allow you to do very smart, very user-friendly, very readable placement to be able to customize visualization. And so this is kind of what we've seen throughout other industries, right? And actually, if you look at what's going on in SysML 2.0, and I don't know which of you attended Sandy's talk yesterday, but in SysML 2.0, we're really focusing on tackling these types of problems for your model-based engineering environment, right? And so that includes things like interoperability. That includes things like integration of analysis. It includes things like usability, right? Which are not focus areas in SysML 1.0, but are increasingly critical to the way systems engineers have to work to bring on board all these people who need to understand what it is that you're doing so that they can do their job better, right? I mean, systems engineering in a vacuum is a useless discipline, right? It is in coordinating the other disciplines together that you really create value and do powerful things. And it turns out that downstream of all of these capabilities and enabling people to actually get at them is this visualization piece of the puzzle. So, if we imagined our perfect solution, right? If we said, well, what if we could just dream something into being? What would it look like? Well, it would resolve this manual effort, right? We would no longer spend 80% of our time arranging and rearranging blocks on a page. We would just model, right? It would be data-driven, right? So it would maintain that model centricity but it would maintain the model centricity all the way to the visualization level, right? So your diagram itself would be a product of the data, not a product of human intervention. It would be interactive, right? So that anything you wanted to do, from filtering to zooming in to drilling down to semantically compressing or expanding nodes and edges and things like that, that would all be there, right? It would be user-friendly so that if you needed that UML look and feel, right, you could have it for your rigorous modeling step, but at the same time, you would have a version of it that would be no work to produce, that would be usable by technicians, that would be presentable to your management and your executives, and that you could show to domain engineers and SMEs so that they would understand what you're trying to convey and how they fit into the picture and how they can contribute to the overall effort of producing whatever it is you're modeling, right? And it would be widely accessible because all of these things are only good if people can actually get at the model, right? So you basically need to unlock everything. And so when you think about this, how would you architect a solution that would actually do that? And it turns out that this concept kind of already exists, right? You have data, right? You have your model. Hopefully most of it is in Magic Draw, but we know that probably some of it lives somewhere else in some other type of data store. And you know that at the end, what you want is a set of interactive views that reveal to you your model through whatever lens and whatever filters you need to see it. And there's this concept, right, in SysML called a viewpoint. And the SysML definition of a viewpoint is like 2 sentences, and it's very hand-wavy, and it's like, oh, well, this is a way to transform your model into a view. But that's kind of it. So you have to start filling in this box. And the way you fill in the box is you say, okay, federated data, right? I need to federate all of my sources together. And I swear Mike Benarsek did not send me a cheat sheet before I made this slide. But it's really, really key that you need to have a federated model of your data that reflects not only SysML, but also other data that you may bring in and unifies them together in a single conception of what do I care about in my system. Then you want to process that data somehow, so you want to filter it down, you want to run some type of analysis, you want to do any type of model transformation operations, and then you want to talk to some set of rules that can create views, and then on top of that has some form of automation so that once I've created all of these blocks and connectors and associations, that it's going to arrange them for me so that I don't have to do that work, and it's also going to make them look pretty, right? And it turns out that we did this. So Tom Sawyer Perspectives is a product that we built starting about a decade ago. We didn't know that this is what we were doing, but it turns out that in practice what we have done is create a viewpoint execution engine. And so this has been employed by a variety of companies who are in this MBSE space. And we're going to talk a little bit about them. So we've anonymized them to protect the innocent, but if you want to go on a scavenger hunt, you can probably find all of them in this building this week. So the first case study I want to talk about is Aerospace, right? So you had an aerospace organization, and they had this need to create a mission handbook, right? So they had their model, but when it came down to executing, they needed a document to put in everyone's hand that everyone was going to read, right? And in this document, they had 75 diagrams that they were building in Magic Draw. They knew the model was right, but just keeping them up to date for every revision of the documentation book was taking them about 150 engineering hours, right? So this is, an engineer month of work dedicated by modelers not to modeling, right? I mean, that seems a little weird when you think about it, right? But that's the reality. I'm sure all of you have felt this pain as your models have started to grow, right? And the other thing was that they got inconsistent results because there were humans placing all of these objects in their drawings. They were never quite sure from one page to the next if everything was going to match because, maybe Bill did one and Susie did another, and Susie has a slightly different style. And so the way we did this is that they had these Magic Draw models, They exported the data. We ran them through Tom Sawyer perspectives, right, which is just the viewpoint execution engine. We defined a set of custom images, and we defined layout constraints. So we're looking at a picture of a satellite. So let's say they wanted, in all of their diagrams, if something was typed as a satellite, it needed to be at the top. If something was typed as a ground center, it needed to be at the bottom. And then all of the interesting components in the middle would just get arranged so that they were connected in a very readable, user-friendly way. Right? And what happened was that when they implemented this form of visualization approach, they went from 75 diagrams in an engineer month to, by their final release of the documentation book, they had 400 diagrams, and they were approving all of them in 1 engineer hour. Right? So that's about a factor of 800 improvement if you do the round math, which isn't too bad, right? And they got consistent placement and style so that whenever you turned the page, you knew exactly where to find things, no matter what exactly was in the diagram. You always had the same semantic representation. Right? We had another contract engineering firm, right? And they needed to place more competitive bids. And they had done an analysis and were looking for places where they could cut hours to be more competitive. And they discovered that they had these 100+ diagrams in a bundle, and they went back and they counted up and they realized they were spending over 1,000 hours over the life cycle of a project just moving blocks around and approving diagrams after the model is built, right? That's not small change, and so they ended up with results that, again, were still difficult to read for non-experts because they were in this UML style. And so what they needed to do was figure out a way to handle this, and they decided that what they were actually going to do was just export all their data to XMI, right? They were going to create a bunch of automated views with filtering and the ability to interactively add layout constraints. So they didn't have the same type of, a priori semantics where you said, okay, satellites are always going to be on top, right? They had to figure out, based on interactivity, where they wanted stuff to go. But there was types of stuff that they knew always went on top, always went on the left, always went on the right. So they decided that they would go through an interface that would let them click on objects to do it. And the result was that it took us about 3 days to figure out exactly how to handle this problem. But then the full suite of 100+ diagrams was created initially in a matter of seconds, and then they went through a process of revision where they spent 5 to 10 minutes per diagram, and they said, okay, well, this is the set of constraints I want to apply here, here, and here, right? And then they had this, and for all future revisions, they just maintained this set of constraints, which they could then apply again over and over again, and it was seconds to create future batches of diagrams. So again, this is many orders of magnitude saved because they let the modelers just do modeling, right? Which is really what you want them to do. We had a consumer goods company come to us and they said, okay, we need to reduce our time to market, right? We're not agile enough. We need to outcompete, and right now it's just taking too long to get through our systems engineering cycle. And they had this problem of laborious diagram generation. They would get asked for diagrams or asked questions which were best answered by diagrams that they didn't have, right? And so they needed to manually redraw these diagrams often, in PowerPoint or Visio, so that they could even present them when people needed to see them. And they decided that they were going to take us, integrate us with a desktop tool, integrate us with a standalone web client via a service to access the model, right? And they were going to create a uniform experience for their modelers for generating diagrams in both desktop and web environments based on a known underlying topology, right? So if you say, I want to create a block definition diagram, you can describe fairly simply, okay, well, this is a block. It's attached by association, attached by, aggregation, right? And you can describe fairly simply what is a block definition diagram supposed to look like from a particular reference block, right? And so this is what they did, and it gave them the ability to instantaneously generate all of their diagrams in desktop or in web, so that, again, they just completely eliminated this step, and it gave everyone that needed access to this model instant access to it with exactly the slice of the model that they need. All right, so we worked with No Magic on several of these types of integrations, and we kind of came to the conclusion that while doing it one-off is great, and it was really great for those particular customers, that it would be easier for us to extract out the essence of what had been done that was shared between these efforts, and let us provide complementary expertise, right? So Tom Sawyer hasn't spent 20 years building, the most loyal representation of SysML, right? That's No Magic. And No Magic hasn't spent 25 years building the best graph visualization technology in the world. That's Tom Sawyer. But together, we can create this, very powerful technology that really solves a lot of the problems that we see repeated over and over again in these types of customers. So just to illustrate some of what's going on, and actually we have integrations with Magic Draw and Cameo on the desktop. We have a web integration that's going to work with Teamwork Cloud and Collaborator that's in a bit earlier stage of development. Just to kind of illustrate these concepts, I'm going to briefly jump into the tool. This will not be a lengthy demo, but I think it will help make it a bit more concrete. And then if you want a bit more information, you can come by our booth, or you can stop by the demo theater. So here is a block definition diagram, right? This is the hybrid SUV model. This is the SysML 1.x reference model. I'm sure many of you in the room have seen it. And here is just, a small block definition diagram. And, just for fun, you can say, okay, I want to render this instead as a Tom Sawyer perspectives diagram, and you'll get something that's a little bit different, but that maintains all of the same semantics. So here, we can see that this is a very conveniently viewable model. It is described by all the same attributes that we've pulled in from the Magic Draw model. And we also have the ability to view it as a custom diagram style with icons, right? So this is something that you could drop directly into a PowerPoint, and it's one click away, right? We also have the ability to do somewhat more interesting things, right? So let's say I'm interested in what is the block definition diagram that contains this hybrid SUV system, right? And I don't have in my Magic Draw project this giant diagram that contains everything that could possibly be connected to that, but it turns out we can generate it very easily, right? And so here we've generated this system, and we can zoom in on it and see all the fun stuff that's going on, right? But we can also say, okay, well, I know I started from that system, but what I'm really interested in is maybe like the power subsystem. So I'm just going to search for the word power. I'm going to find the power subsystem. Okay, there we go. That looks right. And I'm just going to go ahead and click on it. And I'm going to be cursed by this being a demo. But yeah, so we're going to, what happened here? I have a backup video. So basically, we're going to be able to take this and filter it down so that it is, there we go. Well, let's see if I can just get this to kick back on for me. So this is all brand new software, as you might imagine. This is going to be a bit more capable and user-friendly here in the coming weeks and months. So now I've selected on this power subsystem, and I've filtered out everything that was not related to it. We're just going to do a quick layout to bring everything back together. And I'm going to say, okay, so if I'm interested in this power subsystem, I've still got a pretty decent sized diagram here, and maybe this is actually more information than I need. Really what I'm interested in is how the power subsystem is connected to, let's say, the fuel system, right? So here's the fuel pump. We're going to select these, and we're going to say, okay, just bring me stuff that's between the fuel system and this power subsystem, and now we've very quickly created in just a couple of clicks exactly the diagram that I might want, right? And we still have the ability to see it in this custom iconic view, right? And again, we can do a layout to see how it might look with different styles applied, right? So this is the type of thing that we're able to reveal, and similarly, we can generate, do analysis and generate off we could jump to this guy in the containment tree and do it from there, or we could generate an IBD that represents the internals of that. Again, this isn't an IBD that exists inside the model, but we can, come in here and say, okay, so here's the simple version. Well, actually, I'm more interested in what's at the full depth. So actually, this whole IBD is in here. And I can come in and say, let's see. Again, let's look for like a wheel. So here's like a wheel hub assembly. And I can see that I have a wheel that's connected by one of its subcomponents to the tire, which makes sense. But in this model, we actually don't have a direct connection between the wheel and the tire itself. But if we collapse it, we can actually maintain these nested relationships that will continue to express that information, or we can filter it down and, again, only show things that are relevant to a particular subsystem of interest, right? And again, with the custom diagram style. So I'm not going to spend a lot more time on this demo. I think that you are getting the picture. So if you are interested in a bit more information about that, we can give it to you either at our booth, or my colleague Chris Tanner will be in the demo theater in just a few minutes. So you can come by and talk to him. You can drop off a card in our booth if you're interested in learning more after the show, or we're giving away a couple of Starbucks gift cards and a drone. This is Texas. You got to have something fun to give away. So if you drop a business card in the bucket on our table, you'll be entered for that, and we'll be drawing that early this afternoon. So yeah, are there any questions? I think we just have a couple minutes left.
So when you create the visualization, is there a way to bring it back over into like the container tree and make it an actual model diagram?
So for those who couldn't hear, the question was, can you push the diagram back into the containment tree and make it a model diagram? And the answer is not today. But so the schedule for this is that we will be making a public beta of this plugin available sometime late this summer. We're targeting August. It may be a little sooner, maybe a couple weeks later, but it's going to be late summer. And at that time, that capability will certainly be in there.
I know the purpose is to quickly generate a meaningful diagram, but after it auto-generates the diagram, do I still have the ability to move things around if I so choose?
So the question was if you still have the ability to move things around after the diagram is generated. And yes. So the diagram is fully interactive. You can filter, so you can even do things like filter by stereotypes if you have a particular stereotype you don't want visible on the diagram. You can drag individual objects, and we have an algorithm that's called incremental layout, which will say, okay, this was on the right, I really wanted it on the left, I'm just going to click incremental layout, and it's not going to move everything around, it's just going to shift it all so it still looks nice, all the routing is clean, and we're going to have this block on the left instead of the right.
How are you federating to external data sources?
So that's going a little bit deeper into the technology, but basically Tom Sawyer Perspectives is made to render data in the most abstract sense. And so for the past decade, what we've been doing is federating data, and we have we basically have a framework set up that we call an integrator framework, where you can write queries against a SQL database. You can write REST queries against a REST service. You can write Cypher queries against Neo4j, and you can then map them onto your model, right? And so this is all built in, and actually inside of the plugin code, there are hooks that say, okay, I want to define additional integrators, and you or our services team could very easily go in and define these additional data sources that you want to integrate and plug them in either into the web version or directly into the No Magic Thick client, so that your No Magic Thick client then becomes the core of your data federation, and you can see everything right from there.
Can you make edits to the metadata from contour perspectives, or at least make comments that get back to the metadata?
So the question was about making comments on the metadata, and the answer to that, again, is just not today. So This is still a couple months away from our beta release, and we're going to be working with both our our customers and our evaluators, as well as the Magic Draw team themselves, who have been actually exceptionally helpful throughout this process, to figure out what are the exact features that we're going to target in that release. So we have a few things pegged down, but a lot of it's still up in the air. And if there are things that you care about and you're interested in having this solution, then just let us know, and we're going to be prioritizing what features need to get in there. So yeah.
Can you render the data described by the model?
Generally, yes. So it just depends on how you get it in. So one of our largest applications out in the field is Cisco Prime Network, as Cisco's flagship network visualization or network monitoring product, and it is all built on Tom Sawyer perspectives. So if you imagine that you are building an enterprise architecture, you could absolutely have a view of the real network and the real set of what's running in the cloud where, what are my machines, what's the load balance looking like, and you could absolutely have the representation of the real system running next to the model and in the same environment. Yeah.
So one of your use cases was generating a document.
Yeah.
Can you say a little more about how that works?
Sure. So when you've generated a diagram, or when you have a diagram, you have the ability to export it either as an image or through printing. So we support multi-page printing. We support export to any image format, and you can run it in an interactive human user mode, or we have a headless mode where it just generates the diagram and then dumps a bunch out. And in the use case where 400 diagrams are checked in an hour, they just run it headless and then scan through each of those documents. Was like, yep, looks right. Right? So they're not going in and manually creating those. We're fast, but we're not that fast. So, anything else? All right, like I said, Chris will be over in the demo booth. You can ask us anything at our booth, which is right across the hall. Thanks so much, everybody.